Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is the quadratic equation. What we are going to discuss today is how to make a perfect square trinomial. So let's begin. After completing the very lesson today, my dear student will be able to make a binomial expression into a perfect square trinomial. And number two, also be able to factorize that very perfect square trinomial. These are the two things I hope my dear student will be able to do after completing the very lesson today. So as usual, my dear student, your favorite segment of the lesson, that is maths is fun. Today, I'll give you another interesting number. This number is 145. This is so special, so amazing, so unique. I'll tell you what is amazing about this very number 145 after completing my lesson today, so don't go away. To begin the lesson, my dear student, let me just remind you numbers that we call the perfect square. Numbers, that is numbers such as 9, 16, 25, and so on. This group of numbers are called perfect square numbers simply because each of these numbers can be written in index form with a power of 2. Like 9 is nothing but 3 raised to the power of 2, that is 3 square. 16 can be written 4 square, that is 4 raised to 2. And 25 can be written 5 square, that is 5 raised to 2. These numbers are called perfect because of this characteristic that can be written in index form with a power of 2. So it's not only numbers that are perfect, expressions to 2, that is algebraic expression, can also be perfect. Let me just give you examples of some that are perfect. X squared minus 4x plus 4 is a perfect square algebraic expression. X squared plus 3x plus 25 is another example of perfect square algebraic expression simply because of the same reason here, that is writing these numbers in index with a power of 2. So this expression 2, we may have another expression that have a power 2 that is equal to this. Let me just start with the very first one. So x squared minus 4x plus 4. This expression by the left is equals to the expression I have by the right, and what I can see by the right is x minus 2 in bracket, and that bracket raised to the power of 2, which means if I am to expand this very bracket, what it will give me back is my left-hand side, x squared minus 4x plus 4. The second perfect square algebraic expression, x squared plus 3x plus 25 equals to, so this can be written as another expression by the right-hand side with a power of 2. That is x plus 5 in the bracket, and the bracket raised to the power of 2. So if we expanded this, surely is what you're getting back is your left-hand side. So in this very lesson, what we're going to learn is how to make algebraic expressions that are not perfect. How do we make them perfect? So let us move. To make an expression into a perfect square expression, there are rules, there are guidelines. Let's see the rules. So it says to make a binomial, ax squared plus bx. This is the general binomial expression. To make this binomial into a perfect square trinomial, will now have 3 terms. What we say is do the following. So number one, it says make this the coefficient of the squared term unity. That is this ax squared, the coefficient which was a before. We have to make it 1, just x squared. How do we do that? We now divide the terms by that very coefficient of the square term. So when with that division is now done, you now have x squared plus bx all over a. It is initially bx. When you divide bx by a, you now have bx over a. So next step, it says now divide that coefficient of the letter term, that is your coefficient of x, which is b over a, divided by 2. So you divide b over a by 2. After division by 2, you now have b over 2a. Step number 3 says you now find the square of this b over 2a. Then the last step is now says this b over 2a square. You now add it to this very expression, x squared plus bx all over a. And when you now add it, now have going to have 3 terms, and this will now be exactly perfect square expression. This is what we shall be doing to make a binomial into a perfect square trinomial. Just this the 3 to 4 steps. Make the coefficient of the square term 1. Find the coefficient of the lettered term and divide it by 2. That result, after dividing the coefficient of the lettered term by 2, you now square the result. and it is that final result that you are going to add as another additional term to make it 3 terms. And after adding it, it will now become a perfect square trinomial. And if this is perfect square trinomial, we can now write the factorization of this very trinomial as x in bracket plus b all over 2a, and the bracket raised to the power of 2. You see this trinomial is the same thing as the right-hand side, and you can see the right-hand side is having something in the bracket raised to the power of 2. So what I would like you to observe here is what is in the bracket. If your expression is in x, you write x first. If what separated the square term and the letter the term is addition, you now write addition. If it were subtraction, you now write subtraction. Then the next you now write is half the coefficient of that lettered term. The lettered term, its coefficient is b over a. Then half of it is now going to be b over 2a is what you now write as the second term in the bracket. And that bracket always raised to the power of 2. So let's just move and take examples. Example number 1, it says by adding a suitable number, make this binomial x square minus 3x a perfect square 1. So solution to this very problem. So what we do first is to copy down that very binomial. So what we do first, step 1 is to make this coefficient of the square term 1. It is already 1, so step 1 is now done for us. So what we now do is to look at the coefficient of the lettered term. The coefficient of the lettered term is minus the 10 there. So we have to find the half of it. So let me do that. So coefficient of x, that is the lettered term, is now minus 10. So I'm going to find the half of that very coefficient, which gives me minus 10 divided by 2, which will now be minus 5. Then what I'm going to do next is to now square this minus 5. That is half the coefficient of the lettered term. So 5 it is square. That it is square will now be 25. That is minus 5 times another minus 5. So it is this 25 that I'm going to add to x square minus 10x to get 3 terms. And that trinomial is now going to be surely a perfect square trinomial. So let me do that. So I'm going to copy this x square minus 10x. Then I'm going to add the term number 3 to make it a trinomial. And that term number 3 is now this 25. So adding 25 with this expression is now surely a perfect square. Let's just move and take another example. Example number 2, it says by adding a suitable number, make this very expression 3x squared plus 6x into a perfect square trinomial. Solution to this very problem, copy the given binomial, that is 3x squared plus 6x. So what step number 1 says, we have to make the coefficient of the square term 1. In this case is 3. I would like to have just x squared there. So what I'm going to do is to divide through these two terms by that coefficient of the square term, which is 3. So I'm going to divide this 3x squared by 3, divide 6x by 3. After this division, I'm going to have x squared plus 2x. So step number 2 says is to identify the coefficient of the lettered term. The lettered term here, look at it, is this x, and its coefficient is 2. So if I identify that coefficient, so the coefficient of the lettered term is now the 2. I'm going to half it, divide it by 2. So half that coefficient is now going to be 2 divided by 2, which gives me 1. So what I'm going to do next is to find the square of 1. It is this square of 1 that I'm going to add to this x squared plus the 2x to make it a perfect square trinomial. So let me find the 1 square. 1 square is 1. So it is 1 that I'm going to add. So adding 1 to this x squared plus the 2x surely is going to be perfect square trinomial. This is how we now make a binomial into a perfect square trinomial. So let us move and take another example. Example number 3 says by adding a suitable number, make this very expression 4x squared minus 5x into a perfect square. Then after we make it a perfect square, then the question asks to factorize it. Solution to this very problem, copying the given expression for x squared minus 5x. What I'll do first is to make the coefficient of the squared term 1. So this 4. I would like to have just x squared, not 4x squared. So I'm going to divide through by the coefficient 4. Let me do that. So I'm going to have 4x squared divided by 4 minus 5x divided by 4. After this division, if done correctly, you now have x squared minus 5x all over 4. So what I'm going to do next is to identify the coefficient of the letter. The term in this case is minus 5 over 4. Let me write it. Coefficient of x is now minus 5 over 4. So what I'm going to do next is to find half of it, that is divide it by 2. So half that the very coefficient is now going to be minus 5 over 8. That is, I multiply 5 over 4 by another fraction 1 over 2. So 5 times 1 gives you 5, 4 times 2 gives you this 8. So this is half the coefficient of the letter term. So next I have to find the square of this result, minus 5 over 8. So I should square it. So the square of 5 over 8 gives me 25 over 64. So it is this number that I'm going to add to x squared minus 5x over 4 to make it a perfect square trinomial. Let me do that. So I'm going to have x squared minus 5x over 4, which I just copied. If I add this 25 over 64, this will now be a trinomial, and that trinomial surely is going to be a perfect square trinomial. So let me add 25 over 64, and this is now perfect. But the question says I should go ahead and factorize it. I should go ahead and factorize it. So the factorization of this is now going to be, look at it. I'll just open a bracket, and inside my bracket, I'll now have x because the expression is in x. It is minus that is separating the squared term and the lettered term, so I have my minus. And what I'm going to have the next term is half the coefficient of that lettered term. The coefficient of x is now 5 over 4. Half of it is now going to be 5 over 8. This is the factorization of this very perfect square trinomial. Let's just move and take one more final example. Example number 4 says by adding a suitable number, make this expression 5x squared plus 40x a perfect square, then factorize it. Solution to this very problem. So copying the given binomial 5x squared plus 40x. What I'm going to do next is to make this coefficient of the squared term 1. So I'm going to divide it through by 5. Let me do that. 5x squared divided by 5 plus 40x divided by 5. This division, if done correctly, you now have x squared plus 8x. What do you do next is to identify the coefficient of the lettered term, which is 8. So coefficient of the lettered term is now 8. So I'm going to half it, divide it by 2. So half that coefficient is now going to be 8 divided by 2, which gives you 4. So next is to find the square of this number 4. So square of 4 is now going to be 16. It is 16 that you are going to add to x squared plus 8x to make it a trinomial, and that trinomial is now going to be a perfect square trinomial. Let me do that. So I'm going to have my x squared plus 8x. So after adding the 16 to it is now going to be x squared plus 8x plus 16, and this is now going to be perfect. The question says I should go ahead also to factorize it. So the factorization of x squared plus 8x plus 16 is now going to be, I'll just open a bracket and that bracket raised to the power of 2. What I have inside the bracket is x, then either plus or minus, but I will just go back to my expression. The sign that separated the square term and the lettered term is addition, so you have addition there. And the next thing you have inside the bracket is half the coefficient of x. The coefficient of x is 8. Half of it will now be 4. So you are going to have 4 inside this bracket. And this is the factorization of this very expression. Was this, my dear student, I have come to the end of this very lesson. I hope you find it resourceful. And let me just move quickly to the last segment. Maths is fun, and explain what is interesting about the number 145. 145, it says, is the one number out of just 4 numbers, all in all, that can be expressed as sum of the factorials of its digits. So this 145 is just one out of only 4 numbers. You all have out of just 4 numbers, and those 4 numbers can be expressed as sum of the factorials of the digits in those numbers. Let me just find out this 145. So which means if 1 factorial plus 4 factorial plus 5 factorial gives me 145. And remember what is factorial? 1 factorial means 1. 4 factorial means 4 times 3 times 2 times 1. Look at it. Remember that 4 factorial is the second bracket. 5 factorial is the third bracket, meaning 5 times 4 times 3 times 2 times 1. This is the meaning of 5 factorial. So if I now find this result, that is the product added together, it will surely give me the number back 145. So 1 is 1. 4 times 3 times 2 times 1 gives me 24. And 5 times 4 times 3 times 2 times 1, that is the 5 factorial, gives me 120. If I add these three numbers correctly, I will surely get 145. So 145 is very, very amazing, very, very interesting number. In fact, it's just 1 out of 4 numbers, which means there is only 4 numbers that this thing could happen. Thank you for your attention. We see more of these interesting things in mathematics in our subsequent lessons.